Hello everyone, this is another National 5 trigonometry video. In this lesson we are set to look at using or introducing the cosine rule to you. So that's this bullet point here. So we can calculate the length of a side of a triangle using the cosine rule, right? So that's what today's lesson is going to really look at. I've got a little starter activity here. What I want you to do is pause this video and have a go at this triangle, just practicing your sine rule technique. Give this a go and we'll see how you get on. Okay, so if you pause the video and had a go at it, well done. Um, you will probably have struggled with it a fair old bit. Let's have a wee look at how the sine rule works out this time. So we'll have a over sine A equal to b over sine b equal to c over sine c. Right, well what do we have? We've got the angle at b, so we'll tick that. I've got side A and side C, so we'll tick them. And we're able to calculate the length of AC, so that's side B, so we'll calculate that. Right, okay. So we've got a complete pairing where we know three of the four bits of information, and what you can see here is we do not. Right? If we were to use the A's and B's, we only know half the information, and if you were to use the B's and C's, again, you only know half the information, and if you were to use A and C, well, again, you would only know half the information, the two sides, and none of the angles. So, it's an important little exercise to do because when I mean, this basically sets out the reason why we have the cosine rule, but when you are um, trying an exercise or past paper questions that are mixed, i.e. the question doesn't say, please use the sine rule to calculate an answer to this, then you will eventually have to come up with strategies to help you spot the differences. Right, I'm going to use a cosine rule for this one, and I'm going to use a sine rule for this one. You're going to have to start coming up with strategies. And I always feel like if all else failed and you forgot the strategy and you forgot how to spot that that particular question was a cosine rule or that particular question was a sine rule, if you forgot and you tried to do the sine rule for a question that you were supposed to use the cosine rule with, you will end up with this scenario where the sine rule won't work. Now, unfortunately, I still find that some people will still fudge this because they think, nah, well, I'll have to use a sine rule. So I'm going to make up a value and kind of keep going. And unfortunately, you'll get very little, if any, marks for doing that. So if you get into this scenario here where the sine rule isn't working, then it's worth giving the cosine rule a look. After we've done all the cosine rule lessons, we'll get on to teaching you how to spot when to use which strategy. But I always feel like that's a helpful thing to put out there right at the very start of the cosine rule work. So here's a little note on the cosine rule. Um, Basically, the cosine rule says that if you know, and this is really, really important, that if you know two sides and the angle in between them, a bit like the same as with the area of a triangle, if you know two sides and you have the angle in between them, then the side opposite that angle can be worked out using the cosine rule. So you can't, this is the same setup as the starter triangle. You can't use the sine rule to work out A, right? There's not enough information. So you the only thing you can do here is use the cosine rule, and that is that A squared equals B squared plus C squared minus 2BC cos A. You can also breathe a big sigh of relief because, like the sine rule, the cosine rule is on the formula sheet. So it doesn't have to be memorized. I'm going to point out something else to you though. we can use, so at the minute, this cosine rule is set up for using side for calculating side A. If we wanted side B, i.e. if we wanted b squared equals, then there's a slight adjustment to be made. What we'll do is we'll have the two sides squared and added together. So if you were calculating b, you would know a and c, so a squared and c squared. Take away 2ac cos of the angle, and you would have cos b. Right, so that's the alternative version of it, if you like, right? But the reason why I like to point this out to you is you can start to build up a little pattern or spot the kind of sequence as to how you would write out the cosine rule for any triangle with any letters. So we've got c squared. So, well, if I was to calculate c, I would know the angle at c and the other two sides. So it would be a squared add b squared take away 2ab cos c. And that's how you can write out the cosine rule for other triangles and for other sides. So it doesn't necessarily need to always be a squared equals b squared plus c squared. Um, don't get too bogged down in it, right? I often find that after I say that, folk get stressed out about, well, I must write the cosine formula out correctly. You don't necessarily, if you wrote one of these lines here out wrong and then wrote underneath that what the correct first line of working is, then it would probably just get ignored. But I like to see people try and make an effort to use the correct formula for the correct sides. It just shows a clarity of thinking um, about things. Okay, so let's have a look at a couple of examples, right? Just the two for you. Here's the first one. Calculate the size of the missing side of the triangle to one decimal place, right? And you can see if you look straight at the triangle, you've got exactly what I said you would have, two sides and the angle sitting in between them, right? So when you've got that scenario, straight to the cosine rule. Now we are calculating side A. So the cosine rule would be a squared equals b squared and c squared take away 2bc cos a. So a squared, so that'll be 24 squared, add 40 squared, take away 2 times 24 times 40 times cos 105. Now, calculator alert, right? Please be very careful when you type this into your calculator. Right? There's a lot of work in there. It's easy to make a mistake with it. Right? If you have one of the black Casio calculators or some of the more sort of fancy Aurora and Sharp calculators, that line of working can get entered into your calculator exactly as it is, and it'll have no issue with dealing with the order of operations, and it will spit out the right answer. Which incidentally is 818.35 dot dot dot, because I'm not clearing the screen. Now, if your calculator works in a bit more of a peculiar way, you may not get that answer. You may get something different to 818.35. If you do, will you please, and you're not sure why, will you please get in touch with me, because some calculators work in peculiar ways and you might need to introduce brackets around the subtraction, for instance, around here, in order to get it to calculate properly, or you might even have to do it in two stages. So please get in touch if your calculator's not giving you the expected answers, and I'll be able to help you out with that. Now, let's continue on. Obviously, this side BC is not of the order 818 centimetres. I would please ask you to exercise a lot of common sense when it comes to these. It's quite common for folk to forget the final step, which is, well, if a squared equals 818.35, a must be the square root of 818.35. Hence why I wasn't clear on my screen, right? Try to be as accurate as I can. So to one decimal place, that gives me 28.6 centimeters, right? It's very, very common for folk to forget to square root, right? It can just be you're in a bit of a rush. It can be something simple as that, and you get down to you get to a number like 818, and you just stick it down because it's not an outrageous number, but it is an outrageous number for this triangle, which is only 24 and 40 on the other two sides. So 818 would be a bit crazy. So please, please, please remember to square root. Alright, so we look at this last example. So this is the one we had in the starter that we couldn't solve using the sine rule. We are calculating side B in this one. So for a bit of practice, the cosine rule for calculating side B would be B squared equals the other two sides A and C squared and added together. Take away 2AC cos of the angle between them. So cos B. Fill in the numbers. So 7 squared plus 10 squared. Take away 2 times 7 times 10 times cos 70. Again, be careful with the calculator. Right? Be careful how you put it in. If you're having issues, get in touch. But that should come to 101.11 dot dot dot. Remember to take the square root. 101.11 dot dot dot. Don't clear the screen, try and be accurate. So when you get this number, you should be putting into your calculator something like square root ANS for this line, so that you're not introducing any premature rounding. And from that, we get 10.1 centimeters to one decimal place. Alright, so that's using the cosine rule for finding a side. I'm going to give you some textbook questions again to do. A couple of the questions from the last lesson you found quite tricky, right? Many of you were getting in touch with me, looking for solutions, which was great. Keep doing that, keep staying in touch, and we'll see how you get on with this. So for now, exercise 18.4, and let's do question 2, 3, 4, 6, 8, and 9. Right, as always, pictures of your work, please. Folk have been emailing me, with I forgot to send them in and things like that, which is absolutely fine. I mean, I completely get that. One of the best things about working with you guys in class is that I can see exactly how much and how well you've all gotten on, and I can't do that working from home unless you're sending me pictures. So send me a picture of your work. Let me know how you're getting on. Um, Even if you're marking them yourself and you know you're getting on fine, it's important that I know you're getting on fine as well. So send me the pictures of your work. Then I'll know how you're getting on, and then I'll be able to plan for how how much and how challenging I can make the work that I'm setting on the Google Classroom, you see. So the more of you that get in touch with me, the better. Next lesson, we're going to look at the cosine rule for finding an angle. Right, that might be this week, that might be next week. It just depends how quickly folk let me know that they've done this task. So cosine rule for finding an angle coming up next. Thanks very much, folks.